Monitoring tools on our applications that they have to give us alerts, but sometimes they're self-correct.
Yep.
So how do you account for those? I mean, you're opening up a ticket on something that could happen that could possibly self-correct.
Yeah. So the application side of things, since at least on the flash array product line, which is our block-based device, these are things that would be outside of the application stack. So these are things at a block level or a SCSI level on the array, which would have a more global impact to all applications that potentially would be sitting on that array. And so we're looking at things at that tier. The application tier, and it's great that you guys have those, are things that self-correct themselves, which is the application doing very similar stuff that we're doing at the infrastructure level.
Great question. Any other questions? So, Chad, actually, it gives us a good segue, and again, I know some of this is a little early because you're going to be talking about some of the newer technologies that are coming out next week, but when we start talking about these machine data platforms and what these look like, obviously flash storage has a direct impact on the performance and the always-up mentality that we have in our infrastructures going forward. Could you talk to us a little bit about what the changes in the industry are looking like and what we can soon to expect?
Yeah, so from an infrastructure base, we're seeing a vast transition between kind of Hadoop-based architectures, which are distributed compute alongside capacity, into kind of Spark and next-generation data processing systems that actually disaggregate compute a little bit from the storage infrastructure. It does a little bit more in memory, so the expectation now is that the performance on the infrastructure level actually needs to be much higher than it was before. But some of the concepts that I talked about earlier about about consolidating all of the capacity and enabling high levels of concurrence assumes that there's some level of disaggregation, because the model of buying more compute and storage at the exact same time, every single time typically you buy one or the other, too much of one or the other, and you also can't leverage all of the compute across all your clusters for all your capacity. So we believe that the transition will look more of enabling a infrastructure that gives you high concurrency and consistent performance with great scalability. Next week we'll be announcing an 8 petabyte box that fits in 20U, and that can go to concurrency levels that are in the 40 plus gigabytes per second. But enable that with all of your compute. So no longer do you need those silos anymore. You can take the compute across all of those stacks and aggregate them together and be able to run on a larger data lake that truly can satisfy the performance requirements that most real-time analytics need today.
That's good stuff. So if I could now, let's transition into the Internet of Things. I mean, you've all touched on it very lightly, but if we could, Steve, share with us what the Internet of Things means to your organization, where you guys are going with it, how you're implementing it, and then I'll kind of down the line if we can with that one.
Sure, we've been collecting a lot of water data, as I mentioned, and now with a lot more emphasis on groundwater monitoring, and there's that type of data is going to grow quite a bit with a lot more sensors in the field. And then some of our tenant organizations like the Energy Commission, they have to get into things like predictive analysis for energy consumption, and so this is where we'll start bringing in data from different power companies, PG&E or even the ISO, and maybe all the way down to residential power meters, so they can, in a real-time manner, start predicting power usage and over the next, in a foreseeable future, so they can take actions as needed to make sure there's a good supply of power for everyone. So those are a couple of the areas. And by the way, the predictive power program that they're working on would be one of those programs that reach across to other departments. They're going to be interested in some of the climate and water data that we provide as well. And so this is where we really see a benefit of, not just a benefit to the citizenry of the state, but also we see a tremendous growth of data that we're going to have to come in, ingest, maintain, and provide analysis in a real-time manner for.
Manish?
Sure. So I think from a use case perspective, I think definitely IoT is getting more and more mainstream now. I think it was a couple of years ago where companies were not sure, organizations were not sure what the use of the IoT data is, but I think it's getting more mainstream now. So, for example, we have a customer in Denver Water. They are the third largest landowner in Colorado. They process about 2% of their water as well. And what they're doing again with Splunk is, they got in Splunk to, make sure the IT systems are up and running. They used Splunk against their customer-facing applications to understand what transactions people were incurring on the website. But then what they did was with Splunk also was taking data from these sensors that were out in the reservoirs. So they have these buoys that are collecting data about the weather, the water alkalinity, the quality of the data itself. So what they're doing now is they're taking data from those sensors and those buoys to understand the quality of the water that's in that reservoir, but then also they are also looking at the data to predict anomalies, because many a times what happens is these sensor readings can go bad, where the sensor might tell you the data is the water is poor quality, but the sensor might itself have failed. So they're using the same amount of data to predict the anomaly with that sensor itself. So they are not only doing that, but they're taking data from their water treatment systems and their sensor data, again correlating that to figure out what was the correlation when the water quality is good or bad. And again, they're combining that data with SCADA systems as well to make sure the SCADA system's up and running. So IoT is having a big impact. The other case study that we have is with Eglin Air Force Base. I think it's one of the largest Air Force bases in the world. We worked with the partner Kenney's, and what they did was basically they took data from sensors within the Air Force Base and power management systems to make their power consumption more efficient. So in scenarios where the buildings were not being used, they could shut the power down and make it more efficient, and they saw like millions of dollars in saving by using data from not only just IoT sensors, but also combining the data with building management systems and energy consumption systems as well.
Chad, how about yourself?
Sure. So I'll expand. I hit a little bit on what we do internally. I'll expand a little bit on some of it. So this data set really has never been democratized. And I think part of the challenge is that there were silos of each of them, plus there was no real great application to visualize these things. Splunk's done a really good job at correlating the data and visualizing some of it, but really there was not really a way from an infrastructure perspective to deliver that. And so what we did is we took the same telemetry data that we were running the same machine learning on top of and started to harness that to deliver users with forecasting, historical analytics that they didn't really have before. And we did it in a cloud-based model that you could really showcase to anybody. You don't have to have proprietary tools. You could be on or off your network to be able to see all of this information. If your CIO wants to know when you're going to run out of capacity, he can go run his own reports because he's got access to that data. This democratizing of this data set is really the most important part to the enterprise, because your data scientists, by the way, are very busy trying to get stuff for the business to drive more revenue, for the infrastructure and all of the ancillary things on top of it for people to optimize their business. They actually want access to that stuff directly for themselves to be able to use. And so we see some great use cases on that side of the house. Other areas where we see customers starting to deploy these systems are both in kind of edge computing devices, where you're starting to see some of the bigger airlines looking to do dumps of telemetry data of engines to determine whether a flight should take right back off versus waiting till the end of the week to see that telemetry data and then figure out if it needs maintenance or such. Edge computing devices are starting to enable higher frequency of Internet of Things data coming into the overall cloud, whether it's public, private cloud, and be able to run big data analytics at the edge and then do deeper machine learning kind of in your private cloud or public cloud-based solutions. Effectively, all of this is really about trying to get higher concurrency, more real-time access, and enable a much better application experience to the users so they can really see the information and leverage it.
Appreciate that. We probably have time for one other topic that I think is interesting. Analytics is important. The collection of the data and leveraging all of that data in your enterprise is important. But what is there a maximum value point that is achieved by an organization, in your opinion? So, Steve, if you want to kick us off, is there a perfect state? I know that perfect's not the right word, but is there at what point do you see that maximum value return on these analytics and solving something
So so if you're looking at what's our end goal or end game, so for us,
Nirvana.
yeah, we have a view that right now they have our science and engineers they have they have questions that they have to answer. They have business demand that's giving them things they need to do analysis and do reporting on. But we know that providing this type of environment, this ability to easily look at all the data that they have available, those questions can lead to answers, which could lead to more questions. They can start doing some ad hoc analysis and some what-ifs on a very massive scale. We do a lot of modeling around climate and water, and to be able to provide an easy way for them to do all those types of analysis on larger scale and more ad hoc, I think is going to be where we want to get.
Sounds interesting. Manish, what do you think?
So I think it depends a lot on the organization and their end goals. So I think I was just looking at this. The headline is leveraging data, and the story that comes to mind is of University of Nevada at Las Vegas. They're a Splunk customer, and so they started using Splunk again for IT operations use cases. They have a learning management system that the students interact with, that the faculty interacts with, and every time that system went down, they would get calls in. They had to set up a support staff and stuff like that. So they bought in Splunk to make sure that the system was up and running, and the students were happy and the faculty was happy. But then I think what they realized was that they could leverage the same data from the learning management system and combine that data with data from students' clickstream data. So what happened was that they got engaged with the behavioral psychologist in the university to understand what leads to student success. Right, so they started mining data from the learning management system as well as the data from the clickstream data, which was where students were clicking. And they found correlations where they saw that, okay, if students were actually taking self-guided tests, their probability of succeeding in that course was much higher. So as a university, their goal was to retain students because they want to make sure they don't get frustrated and move away. Their goal is also to kind of help students progress through their journey and also have higher graduation rates. So by leveraging Splunk, leveraging the data that was being used for IT operations, now being used by the data science team to understand student behaviors, they have been able to improve their graduation rates for the students. So as an end result, basically their end goal is to, as a university, is to make that happen, and they're able to make the maximum leverage of the same data to make that end goal happen. And again, they are using that same data for their support teams as well, where they have seen reduction in the support cases coming through, and then also being able to support more students with a smaller staff. So in the end, it becomes about what as an organization your end goals are and how you can leverage data to apply to it. I think many times we get lost in big terms, but I think it's always good to start with a specific goal. Start small, prove that methodology out, and then expand to different use cases, just like I described with the University of Las Vegas.
So I'd say the question twofold. One, on the data side, I think this is the earliest of days of machine learning and AI. I think this will continue to grow and grow and grow, and you'll never know what you don't know, and so you'll always have opportunities for new views to look into your data sets, find new correlations, and be able to actually bring it all together. From a Nirvana side, on an infrastructure level, I think people are looking for truly scalable architecture. So to be able to go from the smallest environment to as much data as I can possibly pull together without having to take disruption, maintenance windows, or having to rebuy capacity ever. And I just want to be able to have that pool and have it be stable. At Pure, we focused on a few core key tenets. So we wanted to make things ridiculously simple. And I think that was one thing that resonated with customers more than anything else. It should be deployed in less than an hour, and it should be up and running and easy to use no matter what. Anyone should be able to walk up and utilize the device. How many of you guys look at your manual before using this device? It doesn't even come with a manual. It doesn't have one anymore because it assumes that the user can figure it out themselves. They have abstracted away any of the complexity that could potentially have been built into the product and made it so user-friendly that you could be able to utilize it no matter what your background is. We also knew that efficiency was quite important, and so reducing the overall cost model so you could truly scale this thing without being running into those roadblocks of cost were big, plus being able to do it in a form factor that didn't cause you to have to build out an entire data center to get there. We talked about the 8 petabytes and 20U. Today we have a product that does 1.5 petabytes and 7U, which is pretty spectacular. The last part was the consumer consumption experience, and this is the one that actually sucked the worst, by the way. You had to rebuy the exact same thing every 3 to 5 years from an infrastructure perspective because you got bullied by the bigger storage vendors out there to do so. I use this analogy because some people don't quite get this if you haven't procured storage, but you buy a house, let's say, and it comes with 3 years worth of property tax. In year 4, the tax man shows up and says the next 3 years of property tax is the same price as the brand new house down the street. What do? You move every single 3 to 5 years. And your wife or husband's pissed off because you're moving every 3 to 5 years. And the more stuff you have, the more stuff you lose or break, or it's just more of a pain. But you do it because guess what? There's no other way of staying in the house without paying a lot more money than the new house down the street. And so we came up with a model that said, what if you buy a house with 3 years of property tax? In year 4, the tax man still shows up, but your cost to stay in that house is the same price you paid as the first 3 years, if not less. And in fact, our maintenance, by the way, which is the property tax, has gone down 50% in the last 2 years. So you never move. But even better, when you're at work, we remodel your entire house for you. So you get the brand new house experience with never moving and never needing to rebuy the same thing again. This just changes the game altogether when you look at these data sets, because 6 petabytes is what we own just over the last few years. You guys have massive infrastructures. You're not going to want to go migrate constantly to next generation platforms and such. If you can get that new house experience, leverage the data sets without disruption, and not have to rebuy the same thing again, I believe that's kind of the nirvana for it
That's
from an
nirvana,
infrastructure
yeah.
perspective.
Well, I really do appreciate it. I want to open up. Go ahead, Dave. Give me a question.
Tell them to stand up.
Please stand up so we can see you. Thanks. We're friends. We're friends.
The whole kind of overall theme of the data-driven enterprise, what I'm curious about is your experience in the last year or so, and one specific thing, and that is, do you see a lot of organizations still in the position of, hey, I want my enterprise to be data-driven, here's what I want it to do, go find me the data? Or are you seeing more if you got all this data and somebody shows up and goes, did you know you could do this with it? So, okay, we'll start with you because you're laughing.
It's a little bit of, the reason why I'm laughing
It's
is
a little bit of both.
it's
I
a
know,
mixed
but
bag,
you're
yeah.
seeing the trends going, it's like all of a sudden we got all this data, somebody justify it, we'll figure out what to do with it.
So to be completely honest, in the enterprise, I don't think people are leveraging their data whatsoever. I mean, this is like,
I don't disagree with you.
this is like the first run of people starting to finally get access and correlate data sets. I mean, you know, people have like Salesforce, they could correlate with some other series of data set, and they're just kind of starting to realize that, and they can visualize it through all sorts of utilities. Splunk's brought in some really cool technology where now you can take all of your devices and start correlating all of the stuff from their logs, and people haven't even, I think, scratched the surface on what they plan to do with these types of technologies. But I do think that people have the data sets out there, but this whole siloed concept really messes up everything. You now have to buy these kind of third-party tools that somehow correlate a lot of this together, versus having all the data in one big data lake concept, as people have talked about, and then running applications on top of it. Part of this is challenging too because you've got structured and unstructured data sets that all need to be correlated together. So at some level, things either need to become structured and then analyze across the two, or there has to be some sort of abstraction layer at an application level that correlates them for you. And so I think that we're barely scratching the surface, and the reason why I giggle is because I think people are a little bit lost on even how to attack this, and most people are early.
The question is, am I attacking it from, hey, I bought Splunk and all of a sudden I can see into this data that I've had for 5 years, let's do something with it, or is it the other way? You know, I need to drive my enterprise with data. How do I do that? Well, let's go get Splunk and then let's go get Splunk.
More on the first one. I've got a series of data that's sitting out there. At least I'm seeing, but I'm in the valley, so this could be a little bit different world.
That's what I was just asking
But,
perspective. I'm sure it's
yeah.
a mix of both.
Yeah, it is totally a mix of both. But I'm starting to see more people saying we've now been collecting a ton of data,
And now we can
and we've
look
done zero with it. And now we can start actually like looking at it and finding out. So tools like Splunk are really giving people now this new view into their business that they really have never had before.
Manish, is that kind of the same trend you're seeing?
Yeah, absolutely. So I think the thing that you have to keep in mind is like, so you just heard, Chad talk about how they are disrupting the storage industry, right? I mean, and companies are realizing that if they don't use data as a weapon, they're going to get left behind. So Chad talked about how they're leveraging, for example, the data, telemetry data to improve their support services, reduce those costs basically. So they can disrupt the EMCs and other companies. So I think companies are realizing that if I don't use the data, I'm host, right? If you look at the Ubers, the other Airbnbs, so the disruptions that is happening in every industry. So what companies are saying, okay, I have to get serious about the data that I'm collecting. So how can tools like Splunk help me? So the companies that get successful are the ones that again start with a business problem rather than trying to solve the data. If you always start with the data, you always going to get lost. Okay, the format is not right, this is not right, and you get lost in that whole mire. So we have a company called DB Cargo. They are the largest freight company in Europe, and they got caught up in the big data wave as well. They said, okay, how do I use the data? But before they started using Splunk or anything else, they said, okay, what is the problem that we're trying to solve? And they looked at the customer satisfaction was the issue for them, because the situation for them was that a train is delivering parts to Volkswagen. The operator sees an alert. He picks up the call center. The call center guy says, just to be safe, just take it into maintenance. And they had an issue where 80% of those calls were actually harmless. The train could have just gone straight away. So that was the business problem they started with. And rather than collecting data from all the trains to solve all the problems, they said, okay, let me start with 2 trains, 2 different locomotives, and put the data in Splunk. And so they didn't even start with Splunk first. They said, I'm going to take 2 trains, 2 different types to see if I can solve that problem. Then they bought in Splunk, did a small POC with Splunk, liked that situation, solved the business problem, and then they started leveraging data where now they're expanding across their fleet of 2,000 locomotives. So again, start small, start with the data, start with the business problem, rather than bottom up.
I find the perspective interesting, and I will just correlate them to storage guys. We're providing people with more efficient storage, and they're getting all their data in one place and going, holy smoke, I gotta do something with it. Whereas an application guy who's going, yeah, this is expensive, you better know what you wanna do before you start doing discovery with, So it's interesting.
Different perspectives.
And then we're going to ask a customer, because I think that's the best way to do this, is end it on a high note. Steve, Dave brings up a good point. You guys have been collecting data before it was cool to do that, right? Now it's pretty freaking hot and everybody's doing it, and that's pretty great. But what you're probably seeing both sides of that coin now come to fruition finally. So
yeah,
insights?
our pain point right now is the fact that we have all this data, and everybody, all the people who want to use that data, they know that we have that data and they know that where it's at. But the problem is that the access to that data is very cost prohibitive, because that data was gathered for specifically one type of an application. So it's almost like the access to that data is through an application. So the thing that we're dealing with is how do we make it more easily accessible to people who want it? They say, I know that these data sets are out there. Be able to easily go and correlate those data sets together. So that's the first pain point that we're trying to mitigate. Of course, after you ease that pain point, then the next pain point comes up. So.
Well, I want to thank our panel for all of their time. You guys were great. I really do appreciate you providing your insights on what you're seeing in your purview. I want to thank the crowd as well very much for attending and asking some great questions. If we can give our panelists a round of applause, I appreciate it. And like I said, my name is Chad Hodges. I'm with ENS. Feel free to, we're the booth right next to the main stage, so come visit us and say hello, and we'll talk more about what we're doing with all of these technologies. All these gentlemen will be over there answering questions. Thanks.